if you can see all of my workspace here, all of its wonderful glory. If you've seen in some of my other videos, these cells I got from Battery Hookup that are individual, that I've wired together. I've not confirmed that any of these work. I'm just putting them together. Probably not the best idea, but I guess let's confirm they work. Let's see if we get any, yeah, I got 3.1 volts on these that are paralleled. I got nothing on these, so interesting. See if we can pop them on if they the BMS is just off because they're too low. So got our handy dandy charger. Bring our voltage down to 4 volts. Careful there, I got some wires going. All right, 10 volts. Oh, these things are real sensitive. All right. Dude, I can't remember what's plus and minus. I probably won't have that right. Yeah, so these are the individual cells. And plus and minus. So I think this was the dead one. Flip it. Yeah. That's the dead one. There's a positive over here. Just for kicks and giggles, we'll keep them separate. Man, stiff wires are not cooperating. All right, well, we're getting something, so I'm not sure if we're getting any current though. Negative 1.57. Oh, we're getting something. For sure, our battery's charging. So we might just be waking these batteries up. Four, 8. Well, I can't really see anybody. Try to see if I can. Yeah. Oh yeah. Aha. Joey. These are these white batteries are going to be the Powerwall batteries that I'm putting together, and I got a whole bunch of them. Over here. So like 1,800 of them. 3 more boxes of them in there. And just putting them together. So I'm just kind of wiring them together and then paralleling these, and then we'll series them and make a really big battery that can be used for off-grid in case the grid goes down or something. So other than that, just finally got my desk cleared, so I kind of just wanted to sit here in the peace and quiet with my coffee. So if I take this off, in theory, it should have woke the BMSs up, and we should have something there. Battery should hopefully be holding something. We're at 3.6. So I might just let these keep going. Tap that down a little. So one other thing I wanted to share while I'm live, I'll probably share this in a different video. An idea, an electric vehicle idea. In fact, a couple of them. I got a pen around here. Oh, I got a pen. What? My idea is a supercharger the supercharger is charges a Tesla at something like 60 kilowatts. So most people, might have to come a little closer, but maybe I should use a Sharpie. And yeah, I definitely would be able to find things better if I just left them messy. So it charges at 60 kilowatts. A typical house panel is a 100 amp panel. So 100, you just basically would take 100 times that by 240, and it should be somewhere around, so you got 100 amps times by 240 volts. I want to say, yeah, 100, well, yeah, 20 kilowatts. Duh. So 24 kilowatts. So the fastest that you could possibly charge a electric vehicle off of your typical 100 amp house panel is 24 kilowatts. Now a Tesla supercharger charges at something like 60 kilowatts, if I'm not mistaken. Now let's say maybe you got a 200 amp panel. That would basically just double that, so you'd have 48 kilowatts. So you'd have to completely load up your entire house panel just to be able to charge your electric vehicle, something like a supercharger does for Tesla's supercharging network, which would charge your car a lot faster. Now, put that in perspective, a long-range vehicle has about 75-ish kilowatt hours of battery. So it would take a little more than an hour just to charge completely charge from 0 to 100 your battery off of a supercharger. So most house chargers run at about, for Tesla, and Tesla would be the exception, they have pretty high power home chargers. They got about 8 kilowatts for your home charger, and that's pretty fast. A lot of the other electric vehicles home chargers are less than that, 5 to 6, or sometimes even lower, 4, or one that plugs into a normal wall outlet wouldn't be much more than 3 kilowatts. So apply this to the battery, which your battery is 75 kilowatt hours, so you have to apply 75 kilowatts for an hour to charge it or discharge it. Or you could apply 1 kilowatt for 75 hours to charge it. So simple math. And the point being in all of this is, now this is all long and boring stuff, but to me it's not boring. It's fun to think about. The point of all of this is to point out that it's impossible. It is impossible to supercharge your car at home. But I have an idea. And my idea is that you can. Now, the purpose, I guess maybe the purpose of this isn't necessarily to charge it at your home, but to supercharge a electric vehicle on the go. And the best use case that I could think of this for is tow trucks. So we're going to draw a little tow truck here, a little flatbed tow truck. And my idea is that a tow truck can come and save a Tesla and supercharge it wherever it is, without dragging around batteries that then they have to take home and charge. In a really simple fashion, this tow truck will be able to charge the Tesla with a really simple apparatus. Now, you mentioned the heat of the batteries. The heat, we're just going to stick to Tesla, for instance, but the heat of the batteries is managed by the thermal management of the battery management system on a Tesla, and they actually liquid cool. They liquid cool. I want to say they liquid cool and manage and control the temperatures of those, but most of the battery management systems have over temperature or under temperature protection to prevent that type of stuff. They basically have really big batteries, so it doesn't stress the batteries to heat them up and put that much power on them. But to be able to supercharge your Tesla on the go, what my plan that I'm concocting is that we got a Tesla here, sleek looking thing, sleek as I can draw it, and this Tesla is stranded because it has 0%. Now, this tow truck could haul around a generator and maybe be able to charge this Tesla at that 3 kilowatt rating. So if this truck charged this Tesla with a generator, plugged it in, and charged this Tesla with a generator with like a dinky little 3 kilowatt or maybe even like an 8 kilowatt charger, he would have to charge this Tesla for an hour of just sitting there with this generator running in an 8 kilowatt at best charger to be able to get this Tesla to have 8 kilowatt hours of juice in it, which would be, if you divide 75, divide that by 8, and you'd get the percentage of the battery, I guess. So a pretty small percentage, and he may have to drive pretty far just to find a supercharger to be able to get some juice back into it. So my proposal is something different than a generator, but rather a roller system, which where do you see these? Out here in California, you see them in the smog shops. A roller system that the truck would drive up onto, and it has little rollers, steel rollers, that when it drives the drive wheels, it spins the rollers. So this Tesla would have to be jacked up and the rollers be put under the Tesla, and then the truck pulls alongside it and puts its wheels, also the truck's rear drive wheel, on the same rollers that the Tesla drive wheels are on. And they would need to charge it for a second to boot up the Tesla and get it, at least to like 1% or 0.5% or whatever, just to kind of boot it up and turn the thing on. But once they do that, this truck can drive and spin its wheels and spin the wheels of the Tesla and make the Tesla use its regenerative braking, which can do about 60 kilowatts of power, and just in terms of regenerative braking. So it would put a lot of load on the truck. The truck would have to would end up using quite a bit more gas. It'd be like a truck climbing a hill or something, with all the resistance it would have fighting the regenerative braking on the Tesla. But the Tesla would basically be able to supercharge, and the supercharging is built right into the Tesla already without the need of anything other than the ability to spin the wheels. So my plan is that a tow truck has an ability to show up, spin the wheels of a electric vehicle, and use its regenerative braking to supercharge it. That's the plan in short. Probably could have been explained a lot shorter, but it's really hard to fathom the power that goes into driving an electric vehicle. It's nothing like what runs into your home electrical panel at all. It's so much more than that. So that's my one theory. My other theory I'll share with you while I'm live. I'll probably also make a different video, a little more polished later on. I don't even know why I'm doing live stuff, but why not? So my other theory is with an electric vehicle, let's say you do a conversion, and so you're ripping out the engine, right? You're ripping out just about everything except for like the frame. All of this is pretty self-explanatory, but you're doing an electric vehicle conversion. There's a few things that when you rip the engine out, you also rip out that are quite essential, and that is the AC, the AC, air conditioning. You rip out the power steering pump. And you rip out also its ability to heat, the heating elements, which sometimes uses the fluid from the engine, the coolant from the engine to run through, and you heat with the engine heat, the cab inside, so heating. And there's a few other things, but these things are heating and AC and power steering. Although we think that they're essential, they kind of aren't for a car. The little Porsche that I just recently bought actually has none of these. It doesn't have AC, doesn't have power steering, it doesn't have heating. It's a super light car on the front end. It doesn't have an engine, so you don't really need power steering. It steers pretty easily still. But my idea here is for solving this problem right here, the heating. And let me show you real quick how I would do it. Check on my batteries. They seem to be doing okay. My plan is, I will illustrate it here. 2 batteries. Okay, your electric vehicle is going to have to solve this problem in your conversion, your electric vehicle would need to have 2 different batteries. And there's some companies that are doing this already. And I think there's a lot of potential in this type of a concept with electric vehicles, and it's a drive battery and a large capacity battery. So the drive battery would be the type of cells that are capable of really high drain. They have really high drain potential, which means they can discharge just about all of their energy really fast, and it doesn't stress them. They don't heat up, and it can be smaller. So then your high capacity battery would basically be run in parallel with this battery in such a way that the motor and the controller pulls right off of this battery, and then your high capacity battery dumps its juice into your it dumps it into your drive battery. So you'll have two different batteries, and I'll try to draw a schematic, I guess. And in the process, let me kind of explain this real quick first. In the process of draining your high capacity battery into your drive battery, you're going to be able to make a heating element that can be used to heat the cab. And it'd be really simple. You wouldn't need like heat pumps and stuff. It's just a simple solution that you could kind of whip out of a hat if you do an electric vehicle conversion and you do want heat. So the idea here would be, flip this over and draw it. Your drive battery, you got a car, put the, we'll make it a truck just cause. Don't laugh at my drawings. So you got a truck, and we're going to put the drive battery up front. So the drive battery will be here, and the drive battery powers the wheels. So it pushes the juice to the motors which power the wheels. Your high capacity battery, we'll put that in the bed of the truck just cause. So your high capacity battery will, which gives you the distance. This gives you the ability to, the high drain amount that you want for driving the system. But then the high capacity battery, which can be kind of a low amp but high capacity, will dump its juice into this battery. As you use up this battery, it will fill it. So what you would end up doing is make a circuit that if you want the heat on, and it can be controlled by a thermostat or something that switches this relay, that when you want the heat on, it will redirect the power. It would break this circuit and redirect the power through a heating element. And then go into your drain battery. So when this voltage sags from driving it and the power from this wants to go here, when you have the heat turned on, or when the cab is, the thermostat in the cab has this circuit open and it runs this through the heating element instead of just through the wire, the main copper wire, then you'll be able to heat up the cab. So whatever's left over after coming through the heating element will just make it to the drive battery and then go to the wheels. But the wasted energy and the resistance going through this heating element can just be used to heat the cab. So that's my other theory and plan, but it requires a drive battery and a high capacity battery to be able to do that. Otherwise, it might just be easier to use a heating element, which turns on and off. But when you use that heating element without this system, like for instance in the Porsche that I'm going to have, it's not going to have this drive battery and this high capacity battery. When that heating element would come on, if I were to put one in, it would put a load on the battery, my battery. And for instance, if I also put an AC unit in there, that AC unit would put a load on the battery, which takes away from its ability to go into the motor. So just loading up that battery would be, it's just something to think about, something I think about at least. So anyways, I guess we'll check where our battery's at, and then I don't have a whole lot else, but I'm going to come up with a proof of concept for both of those things and test them out, because I can charge my Porsche that I got. I can charge that thing. If I had a little roller system, I could charge it at 200 amps versus, oh shoot, what am I charging it at now out of the wall? 100 times 40, we'll just say it's a lot less. It might be a couple amps. 144, 15, yeah, 200. I might be charging it at 10 amps. And if I could use the regenerative braking, I could charge it at 200 amps. A lot different. Okay, so we're at 3.8. Let's see what happens when we take our charger off. 7. I'll leave my charger off and just see if it's holding. Who knows, maybe these things are dead. That sucked. Oh well. Alright, I think we're done chit-chatting and tinkering with batteries. Be out here all night, I guess. How do I do this? Yes, the one that I have, that Porsche I just bought, does have an AC motor in it that does do that, the regenerative braking. If I were to convert one with something like this motor, it's here, that's just a DC motor, a glorified golf cart motor, and it's harder to make those do the regenerative braking. I've seen somebody doing it, but it's harder to do. But yeah, that helps. The regenerative braking helps a lot. And getting that power back when you stop. All right. How do I shut this off?